Hello, Coach Holmes here, and today we're going to be talking about proving triangles, but more specifically, proving other parts of a triangle that are congruent. Now, what I'm talking about is, we already know how to prove different triangles are congruent. But if we're not given certain parts, we should be able to prove them because the triangles are congruent. And what actually helps us is CPCTC, which is known as corresponding parts of congruent triangles are congruent. Okay? Corresponding parts of congruent triangles are congruent, which basically means, this is what it basically means. Other parts of triangles are congruent as well. What basically saying is that if we're able to prove that the triangles are congruent, then the parts that we don't have are going to be congruent as well. So here's a good example. So I have side, angle, side for this triangle, and triangle XYZ, I have side, angle, side. So I have side, angle, side that are congruent to each other. So by knowing what type of triangle or what kind of postulate I'm using to prove triangles are congruent, I'm using side, angle, side. Now, we're given side AB, BC, and angle B, as well as side XY, side YZ, and angle Y. But we don't have these parts here. Well, because of corresponding parts of congruent triangles are congruent, we can say that angle A is congruent to angle X. Just like how side AC is congruent to XZ. And then we can also say that angle C is congruent to angle Z. But again, all this works only because of CPCTC. That's what actually helps us out. That's what helps us be able to prove that those triangles are congruent to each other. Now, we do want to be able to prove, now looking at this figure right here, I want to be able to prove that AD is congruent to DC. I want to be able to prove that. So, looking at it, it's a quadrilateral with two triangles because of the side in the middle. Now, luckily, each of these angles are congruent to each other. But because BD and BB are equal to each other because they're reflective. So this side right here is going to be congruent to itself. Now, knowing that, I know that this triangle is congruent because of angle, side, angle. So I can say triangle ABD congruent to triangle CBD. And it works because of angle, side, angle. Now, also, because of that, CPCTC allows me to say that AD right here is congruent to DC. Because I know that the triangle is congruent, I can say other parts are congruent as well. So AD is congruent to DC. That's what allows us to say that. Now looking at this triangle, it's two triangles in one, but I have right angles. And this is something I haven't really got a chance to teach y'all. But if I have a right triangle, and I'm given a hypotenuse, which is the length opposite the right angle, and a leg, which is basically one of the sides that make the right angle, then they are congruent to each other. The triangles are congruent by hypotenuse leg. Now, notice right here that this is congruent because it's the same thing. Now, luckily, because of hypotenuse leg, which, by the way, this only works for right triangles. Only for right triangles. Because of hypotenuse leg, I can say MNP is congruent to triangle ONP. So I can definitely say that. Now, what we're trying to prove is angle 1 is congruent to angle 2. But I know that because of CPCTC. By using this, I can say angle 1 congruent to angle 2. So the biggest thing we're trying to talk about here is that CPCTC allows us to prove that other parts of a triangle are congruent as well. Even though I'm only given certain parts, I can prove the other parts as long as I prove that the triangle is congruent. Thank you and have a good day.